In this video, we will proceed and talk about basic Java operations. Just like in any other language, the basic idea behind programming is data manipulation, working with data. And that more than often involves adding, multiplying, subtracting, dividing, and so forth. All those operations that we learn in school, right? Multiplication, addition, and so forth, okay? So how do we do that in Java? Okay, it's very simple. We're gonna go ahead and create a new Java project. So say file at the top, say new. We're not gonna select anything here, just the way it is. Say next. It's gonna be a command line app. Say create project from template. That way we'll have a main method here, the entry point, as it says here. Say next. We're gonna call this basic ops. Say next, finish. In this case, it will ask us if we want to open a new window. We're just gonna say new window, new window. Okay, that's fine. There we go. So now we have a new window here, a brand new project, okay, called basic ops. And of course, you can name whatever you like. That's fine. The idea is that you are able to create a project. And also notice that for the next, as we progress in our studies, I won't go through this process every time. I want you to do it yourself, right? So in the next lessons or so, if there's a new project, I'll just tell you to go and create a new project and name whatever I want you to name or something you would like to name it. Okay, so that way it's not repetitive. Alright, so here we go. Let's talk about basic operations in Java. Let's start with addition. Of course, for addition, the sign we use is the plus sign. So the idea is that we are adding two numbers. Okay, so in order for us to be able to add two numbers, we have to have those numbers. And as we know now, we have to create those numbers. Of course, we could have done something like this. System.out, right? Print ln, that is. Okay, that's the method we want. And say 3 plus 6 and save 9. Should say 9. That's totally fine. So we are using the addition here, operator, the plus, to add these two numbers. But the better yet is to put everything into variables. That way we can just reference those variables. That's the recommended way of doing things, right? That way we have cleaner code and we are more flexible in terms of manipulating or changing things around. Because if we do like this, so every time we have to go and change these numbers here, right? Now when we put in the variables, we can just change into the variables, and if we have a longer and bigger program, then it's easier just to go into the variable and change that number or item, okay, or value, and that will just work better that way instead of having to change everywhere, okay? You'll see as we progress what I mean by that. So now here we're gonna say int, right, because we want to add integers. Say first num is equal to 34, and say int again, second num is 3. Okay, so now again we have first num of type integer, we assign 34, and second num of type integer also we assigned 3. Now what we can do here, we can go ahead and say the sum is, we're concatenating, we can say first num plus second num. Let's save this and run. It says 343. Okay, so we have a problem here. What might be the problem? Try to be detectives here. So we said here the sum is, and of course we are concatenating the string with the values that precede them, okay? But notice we have plus first number and say with plus second num. So it seems to me that it's actually reading, it's not adding it, right? Because it's saying 34, so 34 and add 3. So it's just concatenating these numbers. Well, the reason why this is happening is because remember this plus here, it's a little bit ambiguous in a sense. That means it's hard, it's very contextual, it can have double meaning. In this case here, we want it to be concatenating the sum is string here with the result of the summation of first num and second num. But that's not what's happening. So to solve this problem, to make sure that we let the compiler know that we are not concatenating the sum is and concatenating with the first num, which is going to be 34, and concatenated with second num, which is 3, which is leading to this, 343, because 34 plus 3 is 37, is not 343. So now you see the subtleties that could definitely destroy your program or the results of your program, right? In this case, it's wrong, right? So how do we do that? We put in parentheses, right? So now we're doing that. We're saying whatever's inside this parenthesis here, it's going to be treated as a summation, as an addition. We are adding first num plus second num. And then, once we get a result, we will then concatenate the result right, to the sum is. Now, if we save this and run, we should see 37, just like we want it to be. And of course, we can also do, if we can do addition, we can do subtraction. Okay, and we use the minus sign. And simply, we can keep going and just changing this to minus. Save and run, we should see 31. So 34 minus 3, it's going to be 31. Since we are in the rhythm, let's go ahead and do multiplication. Alright, so the sign is going to be asterisk. Again, if we go ahead here and change this to the asterisk and save, there we go, 102. Okay, now I have a challenge for you. How about division? How do we do division? Well, in this case, we're going to be using the forward slash, okay, for division. So in this case, what do? Yes, you guessed it. Just change that forward slash, save, and gives us 11. Now, here's the problem. We understand that 34 divided by 3, it's not 11, just 11 at least. Let's try, I'm going to use a calculator. Let's see, if we could say 34 divided by 3 is 11.33333333, okay, but it's showing here 11. So the result is not entirely correct. Mathematically speaking, is not correct at all, right? Because we need to show those decimal numbers. Now, how do we do that? So to solve this, simply, we have to change the types in this case. So what we need to do, we have to say, we can go ahead and say double and double. If you save this and run, and you should see 13.33333 and so forth. In this case here, you're starting to see why we even went through the process of learning about types, right? Because the difference here is that, well, we put everything in integer bucket and we divide, but the solution or the result, in this case from dividing 34 by 3, it gave us 11 because we said 34 is an integer as well as the second num, which was 3 as an integer. Well, what happens is that Java can't really differentiate when it comes to results. So it says, well, you just say 34 divided by 3, we're integers, I'll give you an integer. It disregards the decimal points because it says, no, I don't take care of that, I'm just an integer, and let me be an integer. So if I'm an integer, the other person is an integer, if we divide by ourselves, we should show you an integer. So it's your responsibility to always catch that, to always think ahead of what you're doing. If you were writing a program or an application that needs precise numbers by t, in this case by decimal points, okay, you obviously would need to use doubles. Why? Well, because then doubles will give you what you need. In this case, will give you the correct number, the precise numbers. Perfect. So we got that. So the next operator we're going to talk about is called the remainder. Okay, remainder essentially says what remains. Okay, think of it as that. So let's say if we say, for instance, 4, again, the remainder sign is percentage sign, say 4 remainder 2. What this means is the following. It's saying if you divide 4 by 2, what will remain after you've gotten the result? Is there any remainder? Meaning that 4 divided by 2 is equal to 2, because 2 times 2 is 4, and there's nothing that remains. There's no remainder, which means remainder is 0. That's how you should read it. 4 remainder 2 is 0 because 2 times 2 is equal to 4, and there's no remainder. Or in this case, remainder is 0. Another example, let's say if I told you 4 remainder 3, what would it be? What's the remainder? I'll give you a second. 3 goes into 4 one time, right? So 1 times 3 is 3, and what remains is 1. Right? Because then if we divide 4 divided by 3 as whole number, is going to be 1. We can put 2, because then it's going to be 2 times 3 is 6, which is greater than 4. So in this case, 3 goes into 4 one time, and then we have 1 that remains. So that's all what a remainder is. Whatever remains from dividing to 2 numbers. With that knowledge in mind, let's change this to, for instance, 10 and give second 2, just because. And we're going to put here percentage sign. The remainder is, save, let's run. the remainder is 0? Well, because we're saying here 10 remainder 2, right? It's going to be 0. There's no remainder. If we were to put 3 here and save, let's see what's going to happen. It's going to say 1, because now 10 divided by 3, so 3 goes into 10 3 times, and then there's always a remainder of 1, which in this case, we have 1 here. This concept of a remainder may seem a little bit strange in the beginning, but you will see there's a lot of ways or utilities, ways you can use a remainder to calculate a lot of different things, right? Even when you start talking, for instance, talking about algorithms or calculating certain things that you need to calculate or to display on the screen, right? You can use remainders to kind of figure out what needs to be displayed where and how and so forth. Okay, it can get a little bit complicated technically speaking, but the idea is simple. What remains? Learn about some of the basics operations here, namely addition, subtraction, multiplication, division, and the remainder. Alright, and I'll see you in the next video.